Hello and welcome to another Contemplative Friday. So as always, we'll just begin by sitting down or laying down, finding a comfortable position. Close your eyes if you'd like. Begin with a long, slow, deep breath in, followed by a long, slow, deep breath out. And another long, slow, deep breath in to the count of 4 or 5. And exhale to the count of 4 or 5. And another deep breath in to 4 or 5. And exhale to 4 or 5. And one more deep breath in. And exhale all the air, starting at the very base of your gut, squeezing the air out through the lungs, through the shoulders, through the nose. And then release the breath. Just let yourself breathe naturally. Feel the air as it enters into the base of your nose, or focus on your belly expanding as you breathe in and falling as you breathe out. Just focus on your breath. When your mind wanders, just gently invite your mind back to focusing on the breath. And now picture a single ammonia molecule, NH3, nitrogen with 3 H's bonded to it and a lone pair. So the familiar tetrahedral geometry. Picture that tetrahedral. One of the hydrogens coming out at you, maybe make that a wedge, another hydrogen receding away from you, make that slashed. And picture not just one, but let's picture 8 of those. So pop 7 more into your mind. And put those into a beaker full of water. Ammonia is a base, so in that water, maybe just one of those ammonias would grab a proton from the water to become NH4+. So let that happen. That's where we're going to start, a solution of ammonia. Now over the beaker, imagine a burette. And the burette is full of hydrochloric acid, HCl. So fill the burette with H pluses and Cl minuses in water. And now imagine opening the stopcock and dropping in just one H plus into the ammonia solution. What happens to that H plus? It bonds to the lone pair on one of the nitrogens. So one of our NH3s becomes an NH4 plus. So instead of having 8 NH3s, we now have 7 NH3s and an NH4 plus. Open the stopcock again, drip in, let's say 2 more H pluses. H plus is a strong acid, so 100% of it reacts. So now we have 3 NH4 pluses, and we're down to 5 NH3s. Take a moment and picture that ratio. Picture that in solution. 3 NH4 pluses. 5 of the original NH3s with the lone pairs of electrons. Add in 1 more H plus. That reacts with an NH3, converts an NH3 into an NH4 plus. So now we have 4 NH4 pluses, 4 NH3s. We have a 50-50 mix. Of the 8 original ammonias, we've now turned 4 into ammonium ions, and 4 remain as ammonia. What we'll see is that this is a buffer. This is in fact a really good buffer. A mix of a conjugate acid, NH4 plus, and its conjugate base, NH3. And also note that none of the H plus that we've dripped in remains as H plus. It's all reacted because it's a strong acid and there's base present for it to react with. Drip in 3 more H pluses. What do we have in solution now? What does it make? Well, let 3 more NH3s grab an H plus. So we convert 3 of the remaining 4 ammonias into ammonium. So now we have 7 ammoniums, 1 NH3. We're going to add another H plus. Open the stopcock. Drop it in. The final NH3 gets converted into NH4 plus. We are now at the equivalence point in that titration. We have added as many moles of H plus as moles NH3 that we started with, and we've converted them all into NH4 plus. We have a solution of the weak acid NH4 plus. And in fact, a little bit is going to back react with water to form NH3 and OH minus. So we'd actually have a little bit of a basic solution at this point. I'm sorry, the NH4 plus would react with water to produce H3O plus and NH3, and we'd have an acidic solution. So now we've got that solution, mostly NH4 plus. Now we're going to open the stopcock again, add 3 more H pluses. Plop, plop, plop. There is no more NH3 for it to react with. None of the original NH3 is still present. We converted it all essentially into NH4 plus, so the extra 3 H pluses that we add in are just in excess. They will dictate the pH of this solution. Whatever their concentration is determines the pH. Now, of course, we'd also have chloride ions, Cl minus, that we'd be adding every time we added an H plus. So at this point, we've added a total of 11 H pluses. 8 of them have reacted, so only 3 of them remain unreacted. We have 8 NH4 pluses, essentially. Maybe a little less because some is turned into NH3. And 11 Cl minuses, countering all of that charge, because those are spectator ions and haven't reacted. So that's the reaction of a strong acid with a weak base, ammonia, to create a buffer, and then to create an acidic solution, and then to let the excess H plus dictate the overall pH. So picture that solution. Think about that whole movie we just played out in our mind. And return your attention to your breath as you breathe in. Feel the expansion of your belly. As you breathe out, feel it fall. Take another few minutes to relax, be present, feel your feet grounded on the floor. Pay attention to your breath. When your mind wanders, simply bring it back to the breath. Take a long, slow, deep breath in, counting to 4 or 5. Slow breath out to 4 or 5. Another long, slow, deep breath in to 4 or 5. Slowly exhale, pushing out all the air. Take one last moment to empty your mind of thoughts. Focus on where you are, what you're feeling now. Bring your awareness to your fingers, to your hands, sensations that might be in your fingers. Wiggle them, wiggle your toes. Again, just feel yourself in the ways that we don't necessarily pay attention to what our feet are making contact with the ground, arms making contact with the arms of the chair. Gradually open your eyes. Look forward to the day, to the weekend, to social activities. If you have group activities planned, group social gatherings on Zoom or other social media, look forward to interactions with those other people, to a good productive weekend, and I will see you hopefully later on today or sometime next week. Have a good day.